Here's a little bit of homework help for Lesson 3.7, page 213. I've picked two problems. As you can see, this is number 30, and our directions are to solve this inequality by graphing. Okay, so we'll just get right into it. This does not factor, so I need to find the x-intercepts. I need to find the solutions to this quadratic equation. So I'm just going to set this inequality temporarily equal to 0 because technically we solve equations for x, and when we get those solutions, those numbers, if there are real number solutions, they represent x-intercepts for the graph. So since this doesn't factor, I'm just going to go ahead and use the quadratic formula in order to solve this equation. So I'm going to do the opposite of b plus minus the square root of b squared, which is 9, minus 4 times 2, which is negative 8, times 3, which is negative 24. So I'm subtracting negative 24. All of this is going to go over 2 times negative 2, which is negative 4. So at this point, you want to make sure you have your calculator handy. And we're going to get two answers out of this because of plus and minus. I'm going to do negative 3. Let's go and write it down for you. I'm going to do negative 3 plus the square root of 33 divided by negative 4 and get that decimal. And then I'm going to do the same thing for the minus, negative 3 minus the square root of 33 divided by negative 4. And we'll get that decimal. So if you just, I'm just going to pause this, go ahead and get your calculator, and then when I come back we'll see if you got the correct numbers. Okay, so I hope you paused long enough to, with your calculator, come up with these two numbers. And if you didn't, go ahead and stop the video now, and maybe it's the way you're keying it in. Just see if you can figure out what the problem is. And make sure you can eventually get to these two numbers. That's a very important first step. Now that we know what the x-intercepts are, I'm going to estimate where I think those points are on the x-axis. So negative 0.69, just a little bit to the left of a half, negative a half. And then positive 2.19, just a little bit more than 2. Okay, we know that this parabola is going to open upside down. Something else that we know, and we can go ahead and plot this, we know the y-intercept is 3, so I'll just go ahead and put that on the graph. We need to know the AOS, and then from there we can find the vertex. The AOS is in between these two red dots on the x-axis, and since they're estimated, it's okay to go ahead and find out what it is. Just find out the distance between them and divide that by 2. I'm just going to use the AOS formula, the opposite of b over 2a. That will give me the line of symmetry in between these two red dots. So the opposite of b, which is 3, over 2 times a, 2 times negative 2 is negative 4. So the opposite of negative 3/4 is positive 3/4. So my line of symmetry is, I'm going to estimate that to be 3/4. Looks like it's pretty much right in between those two red dots. Okay, well the vertex, well we know what the x-coordinate of the vertex is anyway because that's whatever the AOS number is. And to get the rest of the vertex, you've just put 3/4 back into this function for x. Okay, so literally in your calculator you could key this in, negative 2 times, I'll just change 3/4 into decimal, 0.75 squared, plus 3 times 0.75 plus 3. Alright, grab your calculator. And hopefully you were successful at getting, we'll just round it, 4.13 is the result of plugging the AOS number into the function. So now our vertex is 3/4 and then 4.13, just a little bit more than 4. All right, and so now I can estimate, since my AOS line is here and this y-intercept is 3/4 to the left of that line, then I've got another point 3/4 to the right. And so that's pretty much all I need, the vertex and then these other 2 points. I'm ready to go ahead and draw this, sketch out this parabola. Okay, and I'll just go ahead and erase the AOS line, just clean this up a little bit. Okay, so now we're ready to look at the inequality and answer the question, which really says, where is this parabola? This quadratic represents the parabola. Where is it below the x-axis? For what values of x is this parabola below the x-axis? Well, obviously it's below the x-axis from this x and forever going to the left. Remember, I've shortened this parabola, but it's just going to continue to go down and left forever. Okay, that's a little drastic, but just to overemphasize the point. And over here, it's just going to continue to go down and right forever. So the numbers that represent this parabola, the x-coordinates of this parabola that are below the x-axis, I'll just go ahead and shade it in for you. It's all of these x's from here to the left, going forever, and all of these from here to the right, going forever. Notice all the ones in between represent where the parabola is above the x-axis. Well, that's just the opposite of what this says. Where are they below the x-axis? So now we're ready to state our answer. All right, so it's all the x's such that we have all of the x's that are less than this x-intercept, which was negative 0.69. And since it says or equal to, we're going to include negative 0.69. So we're going to do less than or equal to. Or we could also include all of these numbers that are greater than or equal to this dot, which is 2.19. And that is our answer for number 30 using the graphing method. All right, and I picked another one. Number 42 is from the next section of problems, which says to solve algebraically. Okay, so let's just turn this around. My preferred way of looking at these inequalities, since the quadratic is pointing, the inequality is pointing at the quadratic, just make sure it still is. And let's treat this as an equation, standard form equation that equals 0, and pretty much like we did with the graphing method, we're going to come up with the solutions. Okay, so once again, we have a quadratic that doesn't factor. So we need to find the x-intercepts or the solutions to this quadratic equation by using the quadratic formula, or completing the square if you prefer. So opposite of b plus minus the square root of b squared minus 4 times 2, which is negative 8, times 11, which is negative 88. All of this over 2 times negative 2, which is negative 4. So once again, we're going to need to do some calculator work. So in your calculator, you're going to evaluate this expression. Five plus the square root of 113 divided by negative 4. And then you're also going to evaluate 5 minus the square root of 113 divided by negative 4. Okay, pause the video, see if you can use your calculator correctly, and we'll see what you come up with. Okay, so hopefully you were successful in coming up with these two numbers out of our quadratic formula, which represent x-intercepts. But since we're not graphing, it's really like we're only looking at the x-axis of the graph. And we're going to put these two numbers on this little number line Negative 3.91 is, of course, less than 1.41. And now we're going to just do some testing. And just think of this, since it's or equal to, we're going to actually include these numbers. I'm just going to break up this little number line into 3 sections. Okay, I'm going to test a number to the left or less than negative 3.91, so I'm just going to use negative 4. Okay, I'm going to test a number in between these, and the easiest one to choose would be 0. And then I'm going to choose a number to the right or greater than 1.41, so I'm just going to test 2. So what I'm going to do is take each one of these numbers one at a time. I'm going to plug into this inequality, and you can actually plug into this, either one, it really doesn't matter. They are equivalent. So let's take each one of these numbers one at a time, and we'll see if we get a true statement when we plug that number in for x. So let's test negative 4. Negative 2 times negative 4 squared minus 5 times negative 4. Is that less than or equal to negative 11? Let's see. Negative 4 squared is 16. 16 times negative 2 is negative 32. Negative 5 times negative 4 is positive 20. Do I have an expression? Let's see. This is negative 12, and it definitely is less than negative 11. So what I've proven so far is that the numbers that are less than negative 3.91 are going to make this a true statement. In other words, those numbers less than negative 3.91 will be part of my solution. All right, so now let's test 0, which is a number in between. Okay, so if I let both of these x's become 0, do I get a true statement? Well, I'm going to get 0 minus 0, which is 0, is 0 less than or equal to negative 11? Well, definitely not. So therefore, the numbers in between negative 3.91 and positive 1.41 will not be part of this solution. Okay, and so now let's do the other section. And we're going to test 2. You can pick any number you want, but just don't get crazy. Just choose something that will be fairly easy to calculate. 2 squared is 4. 4 times negative 2 is negative 8. Negative 5 times 2 is negative 10. Do we get an expression now that is less than or equal to negative 11? Negative 18 is less than negative 11. So we've proven that all the numbers greater than 1.41 will be part of our solution. So let's put it all together and state our answer for x. That means the solutions such that all of the numbers less than or equal to negative 3.91, that's what we proved here, or we could have all of the numbers greater than or equal to 1.41. And that is the answer for number 42. So I hope doing these 2 problems from those 2 different types of problems will help you with the rest of the assignment. You're always welcome to email me with questions. Work hard on it, and we will see you next time.